Hello, my name is Charity Weeden, and I'm the Associate Administrator from NASA's Office of Technology, Policy, and Strategy. I'd like to thank the Department of Energy Security and Net Zero, the Royal Aeronautical Society, the UK Space Agency, and the European Space Agency for the invitation to speak with you today. A community that represents hope, determination, altruism, and the innovative spirit of the space sector. I'm sorry I could not join you in person today. Know that your ideas and innovation is leading a path towards a vibrant space community, one that will benefit from science, technologies, and inspiration needed to tackle our harder problems here on planet Earth and as we explore the solar system. The Office of Technology, Policy, and Strategy, called OTPS for short, was created by Administrator Bill Nelson in 2021 to provide leadership with high-quality, evidence-driven advice to shape agency planning and investments. Our goal is to provide timely, useful analysis on issues where NASA is currently engaging in, both short and long-term planning. My office sets its priorities based on direction from Administrator Nelson and other leaders, as well as input from the National Space Council. Our work cuts across NASA to provide our leaders with enterprise-wide perspectives in key areas of technology, economics, policy, and strategy. We are eager to look around corners to see what's coming next and prepare the decisional path with unbiased, unfiltered assessments on consequential issues that are critical to NASA's mission to innovate for the benefit of humanity. Space and Earth sustainability and disruptive technologies are a top priority for NASA. Earlier this year, my office released our report on space-based solar power. We understand and recognize the growing push for sustainable energy and technological innovation. Climate change and economic factors have researchers looking for ways to generate electricity that is better for the environment and cost-effective. Our report considered the conditions under which space-based solar power would be a competitive option to achieving net zero greenhouse gas emissions when compared to other sustainable solutions, and the role NASA could play in the development of space-based solar power systems. We found that space-based solar power systems could offer potential benefits, including the use of power beaming to provide power to remote locations on Earth, as well as near continuous power generation, and that space-based solar power systems could produce carbon emissions similar to other sustainable technologies when developing, assembling, operating, maintaining, and disposing responsibly of power systems. Our report did consider the potential of a space-based solar power system that could begin operating in 2050. We concluded that at this time, the technology still faces several capability gaps that require launch and manufacturing improvements to reduce costs and lower emissions that would make it a competitive alternative. If these challenges can be bridged, space-based solar power could have potential benefits when compared with some forms of terrestrial electricity generation. It could potentially be used where other sustainable terrestrial energy solutions, including solar, geothermal, or hydroelectric, would be impractical. To truly evaluate the potential benefits, more detailed studies are required about the cost of space-based solar power systems versus their potential for net emissions reductions. Now, NASA cannot speak to the strategies of other countries, but we work to foster the development of all areas of space technology within the agency, academic research, the private sector, and with our interagency and international partners. And though the agency does not currently have any programs dedicated to developing space-based solar power, we do have programs dedicated to solving its underlying technological hurdles, especially when it comes to in-space servicing, assembly, and manufacturing, autonomous systems, propulsion, material science, and wireless power beaming. For example, the Space Technology Mission Directorate Game-Changing Development Program is working on a project referred to as PASS. That stands for Precision Assembled Space Structure. This project involves the automated multi-agent assembly of a precision telescope support structure that includes electrical connections. The technology could potentially be used in applications such as fuel depots, radars, and planetary surface shelters, while providing added confidence in assembly as a viable approach to future space systems. On a broader scale, in June of 2023, Caltech made the United States the first country in the world to demonstrate power beaming from orbit to the ground. This achievement was years in the making. Another relevant and underlying essential element to a wide variety of large-scale operations in space is in-orbit servicing, assembly, and manufacturing, ISAM. As a community, we are going to need this capability to build even larger structures in space, to upgrade systems and benefit from the best technologies available, and move defunct systems out of operational highways to ensure we keep space sustainable for future generations. NASA's Consortium for Space Mobility and ISAM Capabilities, COSMIC, was developed in 2023 to make ISAM capabilities a routine part of space architectures and mission life cycles, something space-based solar power systems will need. NASA frequently reevaluates how it approaches capabilities that could support the agency's missions. For space-based solar power, NASA may consider the technology's use cases on places other than Earth, including the Moon. I can understand that for an audience like this that is passionate about the potential for space-based solar power, our OTPS report may have challenged the current norms and paths forward for fellow members of the global space community. But this is only the beginning of the dialogue, and part of tackling tough challenges from an unbiased perspective involves giving weight to facts in ways that may appear to contradict passion. I'm here to remind you that first and foremost, NASA is passionate about inspiring discovery and partnering worldwide to find solutions for the benefit of all. This report will help inform NASA on how to partner smartly on developing in-space servicing, assembly, and manufacturing, autonomy for distributed systems, and power beaming. We recommend working together on future deep dives into the potential for space-based solar power. For those who haven't already done so, I encourage you to read our space-based solar power report in its entirety to fully understand our approach and findings. We look forward to future discussions and partnerships with everyone involved in today's conference, so we can work together to build a better space and Earth environment for us all. Thank you.